In this video, we're going to review how to enter a bridge using the ABC wizard. So for that, we'll open the bridge and we're going to start the ABC wizard. Now, we can of course select what type of bridge we're going to do, and the type of girders or the type of bridge deck I'm going to use. But first will be to get the geometry inside the software. Now, geometry, it could be entered manually, as you can define the type of alignment you have, if it's on tangent, if it's on curve, many segments of the alignment, what is the beginning coordinate of that alignment. So that will be on the horizontal definition. On the vertical one, well, you can enter your own profile and also define the cross section, right? But the easiest way will be to import information or read that information from our geometry software. Could be inroads, could be geopack, or could be also a LAN XML file if we're using another type of roadway software that is not Bentley. So I have a geopack information here and select the alignment that I'm going to use, the alignment that it was created already maybe by the roadway engineers. So I know this is the alignment name, and this is also the profile that they're using. So that profile name is that one. Good. The information has been imported successfully. So here, this is what I have to do by hand if I don't have that information, and also enter the geometry here. This is also the beginning station of the bridge, that for this particular bridge that I have happens to be that is 128 plus 81.48. I know that because of the development plans they have done, and as well I should have entered this by hand if they don't give me information from the GPK file, but I was able to read it from the roadway geometry. The only thing that is left is to enter the information about the cross section. Here I'm going to show you that we have a very wide bridge, so it has 4 planes. Look at the point. 2 is where the profile gray line is running, but as we adding more, I need to move this point inside. So now I have 4 planes, right? So one could be interpreted as the shoulder here, and the middle ones are 47 and 47 feet. Now pay attention to the slopes. The first slope is going up from this point to this point, then still going up in normal crown, but then also from here to this point is going down, and also is going down. Okay, so be careful with that level symbology. And then the profile gray line that it was running on point 2 actually now is running at the center of the bridge, so this will be on point 3. So saying that, I have defined the full geometry of the horizontal and vertical geometry of the bridge plus the cross sections, and the spans, it's going to be 2 spans, could be 3, 4 more spans, and I define it using the span length of 134 here and 134 here. The skew angles could be normal, could be entered as is shown on the screen, you know, in decimal degrees or using a bearing. And for the actual deck, right, what I can use is going to be an I girder, and it's a wide bridge, it's going to be 13 girders, space at 8.5, right? So as you can see, the overhang, it gets calculated automatically here. Kind of specify the thickness. Now the type of beam, we have most of the standards predefined, and you just can pick any one that applies to your particular project, right? So we're going to use maybe an ASHTO 4 in this case. Just hit next. Next step is to define the substructure. So it's going to be a pier. So that pier could be a taper cap, a hammerhead. Let's go with the taper cap pier. Right, define the geometric dimensions, and it's going to be some circular columns, and it's going to be 5 columns. And then the ground elevation that corresponds to the top of the footing here is 135. Right, it could be a footing, could be a combined footing, it could be a crush wall, could be also a drill shaft if you want to. Let's do a drill shaft to follow the example here. 130 on the shaft height, 30 on the depth. Let's do it at 72. Right, column depth. Okay, you just define the dimensions that pertain to your project, you think that you're going to use in your project. So, saying all of that, we just say define the abutment too. The abutment could be a pile cap, could be a stem wall type. Let's do a pile cap as well. Specify the dimensions depending on the project that you have. Right, and I'm gonna copy this to the other one, but first let me define the pile configuration on the abutment. It's going to be a circular pile, and this is the template that I'm going to use. And now when everything is defined, I will say that this abutment, I will copy this abutment type to the other abutment too. Done. So we'll have copy abutment to the other one too. So next, specify the properties. Just go finish it. So I will have my bridge all assembled and ready to go. If I have the ground information, if I want to see the ground, I can also do it with this option. Load the ground and specify where that ground information is. That could be on a form of a line XML file. It could be also on a thing file if I have GeoPag. So let's bring it from a XML file in this case, like a kind of a neutral format. Open it and load the ground information, and now tell the software to show the ground in the 3D viewer. And now I have my ground information loaded on the bridge. I can do a solid view, I can do a transparent view, wireframe mode. So that's my bridge, and now I'm ready to start the design process. And this is how we use the ABC wizard to incorporate my bridge geometry pretty quick. Thank you.